So this is our very first demo videos for our final project. Anyway, I'm just gonna start with the code. So we did a bit of change of the backend and front end code compared to the last lab. But basically did two things. One is so now the chatbot can handle multiple files in one upload. So that means, well, last time you can only upload one files at a time. After you upload more files, after you upload new files, it will cover the embeddings, which there's only one files that can embed it to the chatbot. If you upload new files, the old embeddings is going to change. It's going to be covered. So this time we can upload multiple files at once. You can upload 10 files, 15 files, 20 files to the chatbot. And there is a list that can store multiple files. There is a for loop. For loop can go through all the PDFs, all the files that we upload, and chunks them and getting them vectorized and embedded into our chatbot. And the second thing we change is that we added more one more buttons here, add more files, which means once you upload some files, let's say you upload 15 files to the chatbot and you process it, but you want more data and you want more the chatbot to become more accurate, you can add more data and more files after clicking this. So after you click this, add more files, you can choose multiple files. Again, you can choose multiple files. And then and you click process, it will call the JavaScript process files functions here. And then send the files back to the backend here and call process files here. And notice that there is a new text chunks right here extended. Now you can extend a new text chunks to all text chunks, which means you can update your text chunks. So after you add more files, you can update the chunks here, and then you can update your vectors, which makes the chatbot database bigger. It has more data and theoretically become smarter, the chatbot. So these are the two basic things we did for this demos. We are going to change this after later on, because we are still adding these files from the user interface, but as we all know that the students cannot change embedding, so when they use the chatbot, so we are going to change this function. We are going to move these functions to the backend, which is here the terminal. We're gonna write the terminal interface and adding files from the interface here.
For our final project, we're going to build a virtual nutrition teaching assistant. The goal is to significantly enhance the educational experience in nutrition science courses. This virtual assistant aims to facilitate seamless interaction between students in the vast area of course materials through a sophisticated web interface, which looks like this for now, leveraging the latest in AI and machine learning technologies. So this is what we have built so far, but what we're gonna achieve ultimately is first, a Piazza looks like interface, integration with Piazza to enable automated login, real-time data collection, and prompt accurate responses to student inquiries. Also with chat history, because on Piazza, you can see all the posts posted by students And so what we're gonna have is a similar function here, which is the chat history. And all the students can see. And then besides the PS interface, what we're gonna build is the web forum interface, similar integration with various web forums to support automated login, efficient data collection, and dynamic responses. Besides, we also gonna have custom client set up. It's a development of a custom client or server architecture that includes a secure user database and login system. So this is for the part A requirement, and for part B, we're gonna have different types of data imported to our chatbot to train the model. So first, what we're gonna have is images in topic documents, incorporation of relevant images directly associated with the answers derived from topic documents, aiding in the visualization of concepts. And second is video content. Images from we're gonna have images from associated videos, including snapshots with timestamps and direct links to provide context and further insights. We're also gonna have video transcripts, availability of video transcripts to enhance the understanding of video content and support diverse learning styles. For now, we only have PDFs. And this section is for users to upload files, to upload multiple PDFs file at the same time. But what we're gonna achieve ultimately is to hide this part. This is what we're gonna train our model, but we have already achieved this function in our code. And for the front end, this is actually we almost finished it. So this is very similar to what we're gonna do in the end. But for this left section, this is gonna be the chat history, and the other part's gonna remain the same. So the project is structured around critical milestones that ensure the development and integration of the specified features, focusing on user interaction platforms and multimedia answer capabilities and overall system optimization for an engaging user experience. And this project is so the topic we chose is nutrition. So this project is gonna redefine nutrition science education by combining advanced AI with the user-friendly web interface to create a dynamic interactive learning environment. By meeting the outlined minimum requirements, the project will deliver a versatile virtual teaching assistant capable of providing personalized educational support, enriched with multimedia content for a comprehensive and engaging learning experience. That's what we're gonna achieve in the end. Thank you for listening.
So this would be our project plan. On April the 1st, we would be modifying the back-end app.py code to integrate a replacement-free API as the chatbox LLM, and this would involve the adapting the existing code base to work seamlessly with the new API and would ensure all functional ability remains intact while leveraging the capabilities of the alternative LLM. And on April the 7th, we would be collecting and processing the static data to create a chatbox private database. This would include the gathering data from various sources such as PDFs, text files, web scrapings, videos, and images. We would process the collected data and vectorize them using the embedding techniques to from a comprehensive and easily searchable knowledge base for the chatbot. And on April the 14th, we would be developing the code for processing data from a real-time data source. We would implement the automatic evaluation algorithms to continuously update the embedding database. And on April the 21st, we would be introducing a chat history feature that allows users to record and easily access their previous inquiries. We would enhance the user interface to provide a more intuitive and user-friendly experience. We would refine the chatbot's algorithms to improve its performance, accuracy, and efficiency in responding to the user queries. And on April the 27th, which is the last day, we would conduct through the testing of our chatbot to ensure it's delivered the best possible results. We would engage in rigorous evaluations, fine-tuning, and optimization of the chatbot's performance. We would identify and address any issues or limitation, making necessary adjustments to enhance its functionality and user satisfaction.